They did this standard therapy, tumor comes back. We tried this drug, it didn't work. Let's try a different drug. It's not. So it's the idea of trying monotherapy, trying to hit one receptor, one thing, as if glioblastoma cells are not clonal. They're not the resultant of one mutation that happened and developed all these tumors.
Right.
It only makes sense in the metabolic space to me. So it's like the stem cells, they're all been exposed to the same metabolic issues, and then they all go bad at different times. They're heterogeneous tumors. And so you can wipe out 50%, 70% if they have the EGFR receptor, if the PARP inhibitor works, something like that. If you kill 70% of the cells and 30% still live and even more resistant than before, you've made no dent or a minor dent in their survival. But
Right.
if we treat the entire metabolic milieu that caused the thing to happen in the first place, sensitizes them so that radiation is more effective, or at least, or hyperbaric or something like that, we can save the patient, but change why did it happen. That's really, going at the root cause. So that's how I look at the metabolic therapy as the hopeful answer.
Welcome back to the Smarter Not Harder podcast, your home for 1 cent solutions to $64,000 questions. I'm back as your host today. My name is Dr. Scott Sher, and it's a pleasure to be here with you all today. Are you enjoying the Smarter Not Harder podcast? Please like and subscribe on your favorite platform so you don't miss an episode. We have so much fun recording these and bringing them to you. And today I had a really great time interviewing somebody I think that's really special. And his name is Dr. Kris Smith. And Kris is a neurosurgeon. And I've known about Kris's work for many years. He is one of the rock star neurosurgeons that I've been involved with because of my work in hyperbaric oxygen therapy, specifically with glioblastoma. And so Kris and I had a very deep conversation. We got into the weeds initially, but I hope you guys can just stay tuned as we get to a bigger understanding as we go through the podcast, talking about more. But before I get there, let's talk about Kris's bio. Dr. Kris Smith is an experienced neurosurgeon. He has treated brain and spinal tumors for decades. He, as a neurosurgical oncologist and investigator at the Ivy Brain Tumor Center, Dr. Smith aims to balance minimally invasive techniques with surgical interventions to optimize patient outcomes. He received his medical doctorate from the University of Nevada School of Medicine in Reno, Nevada, and completed his neurosurgery residency at Barrow Medical in Arizona, where he still works now. He's also trained in gamma knife radiosurgery at the University of Pittsburgh, and at the Karolinska Institute for Stockholm, Sweden. He completed his clinical fellowship in epilepsy at the Cleveland Clinic. So he's a longstanding brain tumor and epilepsy surgeon. He's been involved in the work of glioblastoma for the last 30 years. He's authored many peer-reviewed research studies and has had several leadership positions in multiple societies. But the reason I know Kris that is because he does all this work looking at metabolic therapy, specifically the ketogenic diet, and the work that he's doing in clinical trials and the work he's doing in neurosurgery to help patients that he's working with do better, feel better, and have better outcomes overall. And I initially was introduced to Dr. Kris Smith by my colleague, Dr. Naisha Winters, who refers a lot of her patients there. Dr. Naisha was also on the podcast, one of the early episodes. She has a book called The Metabolic Approach to Cancer. And so as mentioned, Dr. Kris and I speak about a lot of different topics in this podcast. We start off going deep into the weeds very quickly on glioblastoma, hyperbaric oxygen therapy, oxygen stress, free radicals, but we pivot pretty quickly on from there, talking about the greater understanding of the metabolic approach that he's been using in his clinic. He's also a metabolically trained athlete. He's a fat-adapted athlete, so he talks about that as well. He talks about his wife's interest in clinical genomics and kind of all these things coming together and working with patients in a research way and getting some research done actually at Barrow, looking at the metabolic approach here, the ketogenic diet, and has a study that he published last year, some anecdotal data, but they're actually doing some prospective data now, which is very exciting on some of the work they're doing with patients, in patients with glioblastoma that are using metabolic approaches and checking things like ketones. We talked about exogenous ketones a little bit. We talked about how there is no glioblastoma in the wild. It's only a disease of developed countries, especially, and how that means that 90% of this is happening because of environmental issues. And we talked about metabolomics and testing, and we talked about mitochondria. We had a fantastic conversation about so many things. So I really hope you guys enjoy this episode with Dr. Kris Smith. He's a wealth of information and somebody that I feel like is doing so much great in the world that he's working in. And I also think that it's much more appropriate not just to think about this just as a conversation about glioblastoma, but as a conversation overall about how we can optimize our health and potentially prevent something like this something like glioblastoma from happening in the first place. So enjoy this episode, and we'll see you next time.
Great.
Dr. Kris Smith, thanks so much for joining us today. How are you today?
Pleasure to be here. Thank you so much.
Well, this has been a long time coming, and I remember the first time I heard your name from Dr. Winters, Dr. Nasha Winters, a colleague of ours, maybe about 3 or 4 years ago. And when she told me that nobody else would do surgery on this guy, but this guy, Dr. Smith. And I was like, who's this Dr. Smith? And I want to learn more about what he's doing and how he's doing it. And so I think maybe a great way to start would be, maybe let's talk about your background a little bit, your expertise, and the center that you run down there in Arizona.
Great. Well, I'm a full-fledged faculty member at the Barrow Neurologic Institute, which is really a special place. It's the largest dedicated neurosurgical hospital in the United States, maybe even the world. There may be someplace in China bigger, but there's no place like it in the States.
Wow.
I was very privileged to match here for residency way back when, more than 30 years ago, and was able to come and train under Dr. Robert Spetzler, who's still considered probably the best neurosurgeon that's ever lived. So I got to train under him, and he became a great friend and mentor and second father figure to me. He's retired several years ago now, but still remains active. So he trained me. He was really an aneurysm and vascular neurosurgeon, but I learned all of these specialty things, and I applied it to both the treatment of epilepsy and tumors. And I got into epilepsy because my first lab project in medical school, I developed a little animal model, a rat model of absence epilepsy, which is really interesting because it's developed. You cause seizures by depriving the little neonatal rats of cholesterol. I never knew that it was going to come around full circle, that cholesterol and fat in the brain and all this stuff was going to come into a real thing. But it turns out to alter the GABA B receptor, and I published several papers. And because of that model and epilepsy model experience, it was back in the dark ages when there were GRASS EEG electrodes on paper. I had reams and reams of paper all through the lab that I had to manually, visually count their seizure activity per hour relative to different anti-seizure drugs and all that stuff. I learned all about neurotransmitters, about GABA receptors, gamma, oscillations, all the EEG readings, all that stuff. So I published a paper, presented national, international meetings. So I was able to match at the Barrow. So the Barrow is considered the #1 neurosurgery residency training program. We get the best of the best residents here from Hopkins and Harvard and Stanford, all this stuff. And it's really a privilege to work here. I have like 34 partners. It's a huge place. We have 11 dedicated neurosurgery operating rooms, which is the only one like it in the world. I typically do 4 or 5 surgeries every Monday, every Wednesday, and I also go out to Scottsdale and operate every other Thursday. And so it's a very busy life. I was already heavily treating patients with glioblastoma, standard of care approach, for years. I wrote as a principal investigator several clinical trials, and I had a trial written, and then my dad. This is after the fact. It wasn't because of him. I was already established as a tumor specialist, and my dad succumbed to a GBM, and so that affected me greatly, terribly, honestly. It was something that. So the protocol that I had written was, the tumors always came back. I thought maybe we can just overwhelm their ability to recover from the onslaught, and so it was. The protocol was gross total resection of the tumor, followed by gliadel implant, which is carmustine, which is an alkylating agent chemotherapy in wafer form. So you put that in at the end of the resection, and then a couple weeks later, you'd bring the patient back and do gamma knife radiosurgery to the resection bed, and then follow it up with standard radiation treatment. So it was a huge, endeavor. This was 20 years ago. It was before temozolomide was part of the standard of care, but it was similar. And we had... And my father was patient number 14 out of 30 prospective patients in that trial. So I watched him go through the whole thing. He and my mother lived with me in my house during the entire 19 months of his survival. So I learned more from that experience than any other thing. And unfortunately, his tumor was in the right frontal lobe, which people generally think of as a very favorable location. But I understood that it was not a great location because your frontal lobes are what make you human, and what makes you organized, what makes you
Right.
have drive for life, have all this stuff. So, and it was really interesting because my senior partner, Dr. Spetzer, actually did the surgery on my own father. He did a right frontal lobectomy. And
Wow.
1 week to the day from that surgery, we played a game of golf together. So he was fine, right? He was
Wow.
able to golf. He was able to be active. He thought clearly. He was contemplating buying another house in Phoenix and, living closer to me because of this disease. And it was really interesting because it was later on I determined that it was the onslaught of all the toxicity of our therapy that ended up probably causing his demise. And I didn't realize that for years, but I really look back on it and say, wow, we did that. So the flip side of that is that another patient 20 years later is still alive. She was patient number 30 in that protocol. She was only 29 at the time, was a single mom, and she's still alive to this day. But her tumor was posterior left temporal location, and it didn't involve her frontal lobes and her motivation and drive and personality and all that stuff. And she has a mild speech and memory problem, but it's really mild, and she's lived a great life. She's able to raise her child. She's actually moved on. She's gotten remarried. She's living still 20 years later after this, GBM treatment. So, but our incidence of radiation necrosis was, 50%. We had lots of, issues of overtreatment.
Right.
But there's still a principle of maybe we could overwhelm the tumor's ability to recover and repair DNA, because recurrent GBMs are ridiculous. They are so bad. We did another study of hopefully I'm not getting too far into the details here this early in the podcast.
No, you're good. I'm gonna circle you back in a minute, but this is good.
Okay, great.
Yeah.
So I was the director of the gamma knife unit, so I've done thousands of cases of very focused gamma knife radiosurgical treatment of metastatic disease and meningiomas and all that stuff, and rarely some GBMs. But the issue is we developed a dosimeter, so you could take the cells out of one of my patients operating. You grow the cells out on a single layer, monolayer, and a cassette. We developed a device where you put the cassette into the middle of the gamma knife, and the center of it gets a 24 gray dose, and then it falls off from there. So you get a 12 gray line, a 10 gray line, 8 gray line, all that stuff, and the cassette. So it's the perfect dosimeter. So when you put the very first diagnosed tumor, one of my patients, you grow their cells out. These are human glioblastoma cells. They're all exquisitely sensitive to the radiation up to about a 14, 12, 10 gray lines, a little different tumor to tumor, but they is a kill zone in the middle, just a clear spot where all the cells die. Same patient, 9 months later, a year later, they've received, radiation, temozolomide. Their cells come back. You plate those out and put them in the same experimental design in the protocol. They are completely radiation resistant. It doesn't matter what we do to them. They're cells that survive the 24 gray single shot dose. It's amazing how resistant they are. So if we're ever going to cure this disease, it's going to be understanding the biology of the upfront initial resection. Recurrent disease is just so difficult and devastating. So anyway, learned a lot from that. And then, but again, the whole idea of when my father was recovering and then declining and became just a complete, vegetative, he would just lie on the couch all day long, do absolutely nothing. He couldn't walk. He ended up putting a shunt in. I found out lots of my patients get tumor-related hydrocephalus from the treatment, can't absorb their spinal fluid anymore. A shunt helped him a lot for a while, but then he just literally lost everything. And I really believe it was because of that excessive toxicity of therapy. So now I'm become much more realistic or hopeful that we can do things that are less toxic to patients, really understand the tumor biology and the metabolism. We'll get into that, but that's where my focus is now.
Right. Well, thank you for all that. I think it's important that, look, you've learned a lot in the last 30 years, obviously as a surgeon, and also what can work and what doesn't work. And, radiation is obviously very helpful, but it can also have significant detrimental effects down the stream. And this is something as somebody who specializes in hyperbaric oxygen therapy that I've seen over the years, how severe these cases can be with radiation necrosis of the brain and how hard they are to actually, I have radiation necrosis in a lot of places where I can use hyperbaric therapy and see dramatic improvements. And when it comes to neurologic tissue, it's not typically as dramatic an improvement. So we've had some minor success looking at it. And maybe you and I could talk about how you could use hyperbaric therapy in the very much the early treatment, so like right after radiation, to prevent some of the radiation necrosis from actually happening if people are at high risk of that. And I've had a few patients over the years that have had some success. We think that they didn't get radiation necrosis as significantly because they got into a hyperbaric chamber after the resection, after the radiotherapy was done very quickly, rather than waiting for radiation necrosis to actually arise. But I mean, that's just an idea.
It's a really interesting concept. I hope I'm not diverting off to a tangent, but one of my concerns with, and I use hyperbaric oxygen, don't believe me, I'm into it, but
yeah,
the issue is it's really the oxygen radicals that are the reason that the radiation therapy works. So excess oxygen is actually toxic, right? So this is a really interesting observation. If you look at the patients that get operated and you take the skin, as incision, and they put the stitches or the staples, and that's squeezing the tissue together. But right at that line where made the incision and squeezed by the sutures, that's a little bit hypoxic, right?
Sure.
So I had many patients that have external beam radiation therapy, and then the only place their hair grows is in that region where the sutures are, because that's where it did not get perfused with oxygen and exposed to the exact same dose of radiation. So if you look at that on the inside, it's like, wait a minute, if we increase the oxygen levels in the brain, then maybe we're actually increasing oxygen radical toxicity in that region. So it's an interesting conversation about what's better, what's worse, right? It could be better for tumor kill, but it could be worse for radiation necrosis. And we know that, also the tumor cells love a hypoxic environment, so we're trying to get them into an oxygen state. Right. So there's all kinds of different pros and cons there. So
right, I think, and then this is kind of where the world that you've kind of been living in for the last many years and mine collides, which is metabolic therapies, and how this may help mitigate some of that oxidative stress of being in a hyperbaric chamber or getting radiation as well. I mean, we know that radiation is obviously oxygen requiring. And we also know that there's different doses of hyperbaric therapy that you can use. You can use like mild hyperbaric chambers or mild pressures, which won't give you as much oxidative load, as opposed to deeper pressures that will cause more oxidative load, but then have different effects and everything. But you have to take it a step back with all of this. And it seems to me that at some point around all this, you figured out that there was metabolic therapies that might be in play here with the ketogenic diet specifically. How did that start becoming part of the way you work with patients? Because I know, Kris, you're not just a guy that takes these things out of people's brains. I know that you're much more of a holistic guy when it comes to understanding how you can work with people. Was this the first way you started kind of thinking more holistically, or what was the impetus to start working with metabolic therapies in the first place?
Well, it's a long story. Hopefully we got a bunch of time.
We got time.
So there's a three-pronged approach here. So number one, I'm a physically active guy. I commute a couple days a week on my bike. It's a 25-mile round trip. I've run in marathons. I'm actually training for another one now. And nice. And we had a resident here. His name was Mike Nanasco, and he's an ultra marathoner. And he gave me a book to read called Low Carbohydrate Living for the Performance Athlete.
Sure.
Because every time I did a marathon, I'd hit mile 20 or 22, I'd literally hit the wall. Your body can only store 3,000 calories of glycogen, glucose, then it runs out, and I have like literally a full-blown, cramp in every muscle in my body, my face, my neck, is just awful. Your body's depleted of glycogen, right? And he gave me this book, and he says, yeah, you could train yourself to be fat adaptive. Even the skinniest Ethiopian has 40,000 calories waiting just to be tapped, and you never run out of energy. So he literally runs, he won the Monument Valley 50 miler by more than an hour of the next competitor. And he was a resident neurosurgery. He was not a professional athlete, but he's completely fat adapted and as a metabolic machine. So I said, wow, I want to do that. So that was prong number one. So I started living this way in my training, and I noticed how much increased energy I had, how much better I was. I gained speed. It was like, wow, this is incredible.
And how many years ago was this? When did that start?
This is about 10 years ago.
About 10 years ago. Okay.
Maybe eight years, something like that.
Yeah, when it was very difficult to know how to do that, right? There was very few resources out there to learn how to be a keto or fat adapted athlete at that point.
Yeah, and so it was great. I mean, Volek and Finney, they've published years and years of research, for 30 years now, but it's really become quite integrated in a lot of athletic circles now. But back then it was like, oh, this is crazy. And then number two, we have a very good researcher that was working here. She's not here anymore, but I still stay in contact with her all the time, Adrienne Scheck. And she she did some really great mouse model research of GBMs. And she was our basic science researcher. The paper I published with, that I told you about already, the little biologic dosimeter with the gamma knife, that was part of her Opticell cassette. Everything was plating out our glioblastoma cells. I worked with her for years. And she started bugging me about, I'm doing this study, this ketogenic diet. I think it might really help your tumor patients. And I'd say, it's the most difficult cancer in the world to treat. What possibly can food have to do? I really was so skeptical. I was like, there's no way. And then one day she gave, grand rounds, and gave her research data. And it had this animal model, and it's still published. It's great data, where you give the mouse the glioblastoma model. You treat them with radiation. It extends their life for about 6 weeks, but they all still die. You give them temozolomide, extends their life 6 months, they all still die. Give them both, extends their life 10 weeks or whatever, but they all still die. But if you give them ketogenic chow, so keto cow, and then you give them radiation, 8 out of 10 rats or mice are all alive and tumor-free at a year. So they're cured. They're literally cured. They autopsy, sacrifice their brains, no active disease. So that's what we have to do in people. Mm-hmm. Then the third leg of the stable stool is that my wife is a dietitian, and she listens to podcasts all the time. She's obsessed with diet and all this stuff, and she's a completely trained nutrition oncology person who's gone through Dr. Dacia Winter's program and all this stuff. But before then, she was reading and listening to podcasts, and at night, dinner time, where she's listening to stuff, and I'm kind of overhearing this, and I'm going, is that really true? I was like, what is this? What's the data for that? I was like, so I get I get the exercise, metabolic, approach to ketogenic adapted athlete. Dr. Sheck pounding on me about treating my patients with the hospital. My wife pounding on me, we got to change our food. And so I couldn't help it. I was overwhelmed with influencers on getting me to think about food and metabolism and cancer. So.
Yeah. Wow. I mean, that's the triumvirate right there, right?
Yeah.
Both in your work life, right. and oh man, that's great. I mean, in the sense that, back 10 years ago, we didn't have a lot of research that was coming out into the community. I mean, the first research trial that I saw on ketogenic diet was, I think, around 2013, 2014.
Right.
And it might've been a similar model. It was a metastatic model of glioblastoma. And this is what Dominic D'Agostino published with Tom Seyfried, looking at hyperbaric oxygen therapy, the ketogenic diet for glio, and doing some research there. And I started getting patients coming through my door because I was working as a medical director of a hyperbaric facility in San Francisco at the time. And I had no idea where to send them or what to do with the ketogenic part. I mean, the hyperbaric part, it's not that difficult in the sense you just sit in the chamber and of course there's protocols and things like that we have to figure out.
The patient just sits there, listens to music. Yeah, there's not a big deal, right?
You just hang out, right? But trying to find resources. So how did you start the process? Because I read something on your website, which you call, I think, precision metabolic therapy. And I think that's kind of what you've graduated to. So how did you, maybe that's the name that you graduated to, but how did you start, and what was some of the initial stories that you were able to, or the people you were able to work with, and how that worked as far as with the radiation, with the surgery? I mean, maybe you can go some of those details, because I think it's really important.
Yeah, no, it was really, I have to thank numerous patients. One of them, unfortunately, he's passed away, but his name is Oscar, and he really changed my life. He was one who...
I know Oscar as well.
Okay, so he had known Adrienne Sheck, and she, said, hey, this guy's got this tumor, he's young, he's super motivated, nicest guy ever, which he is. Yeah. And he said, I really want to do this, Dr. Smith. And he says, so let's, and I said, yeah, I'm into it. We have this animal data, I'll help you through it. And he really didn't, he had a multifocal disease. His brain was riddled with tumor, really was. His entire right temporal lobe, it went deep into the insula and the frontal lobe, but he had another focus down near his brainstem and the cerebellum, the cerebellum peduncle, and just 4 different places of the thalamus on the other side. If they would have done standard of care radiation and all the places had disease, he would be vegetative, right? And he said, I really don't want to do standard of care. I really want to try this. And I said, okay, I'll do it with you. We'll do this together. So we did, the best surgery we could. We did all these. He went through multiple procedures over the years, but ultimately, he's one of 16 patients I published last year in 2022 in Curious about patients that went on ketogenic metabolic therapy and then had a response radiographically, clinically, that I thought was completely out of bounds compared to what I'd seen in standard of care without metabolic therapy. And I still hold to that. It's not a randomized prospective trial. Any skeptics out there can pick it apart and say, oh yeah, patients can do well. You don't know why, all this stuff. But this was, to me, really illustrative. And the most important thing was, in Oscar's case, is that, he was the first patient that was really gung-ho. I mean, he was doing his diet. He was measuring his ketones. He was just really totally engrossed in doing this correctly. And so I saw his scans, and I published this. It's this entire flare abnormality, which is an MRI technique that really shows all the infiltrative disease really well. And I would watch this over months and months, and scan after scan over a two-year period of time, literally just involute and normalize. I had never, ever seen that before with any therapy, right? Wow. So any chemotherapy, we're happy for stability. We don't watch them shrink or the flare abnormality literally go away. So He had a spot in the basal ganglia, the thalamus and insular region that just literally normalized. And so I said, wow, this is unbelievable. And the sad thing is in him is that he's really gung-ho, he's doing it. But he had some genetic defects, not defects, they're polymorphisms or, differences in his SNPs that made it difficult for him to get in ketosis. So what he was doing is he would go in a 5-day fast during his temozolomide dosing, right? And for 5 days, his ketone numbers would go out. He had a ketone number up to 6.9 once. We're happy if they get to 2.5 or 3, but he's 6.9. And this is when everything, shut down. And so when he was doing fasting to be in ketosis, he did great. But he had a PPAR alpha variant that didn't really allow him to be in ketosis by just eating a standard ketogenic diet. I knew nothing about this stuff before that, right? So, sure. So we, and we went beyond the normal boundaries of doctor-patient relationship. And my wife she thought of him as another son in our family, and they text all the time about his diet, his food. And then she invited his family to go out to the lake with us in the summertime. He survived in Phoenix by getting in the water when it's 115. So we took him out to the lake, and he was he couldn't fit into my largest jacket, my largest life jacket. He'd gained weight. And I go, Oscar, you can't possibly gain weight on the ketogenic diet if you're doing it correctly. Something's not right. He goes, what? Dr. Smith, you're calling me a fatty? I go, no, I'm just making a clinical observation. You've gained weight. That's not good. You're not doing it right. And so it turns out he was eating handfuls of nuts all the time, just thinking, they're fine and everything. But he was gaining weight. But he learned to wake surf beautifully. I mean, quickly, faster than most people by far. He was perfect as far as a clinical neurologic exam. Unfortunately, 3 weeks after that observation, he gets a surveillance MRI, starts really having trouble with balance and walking, and he had a new tumor in the brainstem. And then I was like, I was just heartbroken. And that was the start of his real decline, unfortunately. Sure. We never really got him all the way back, but I got him back but we sent off his nutrition genome, and this is what you mean about, precision metabolic therapy, is we found out all these details about all of these SNPs that can really be either pro or con, and being able to maintain ketosis, how strict you have to be, because some people can really just flip in and out of ketosis without a problem, depending on their genetics. But others really struggle. And I think a lot of this, and Tracy, my wife, the dietitian who does all these, courses on the nutrition genome, and with the methylation, the inflammation, the all the, the issues that come up. She has found out, she goes, wow, Kris, all of your patients that have glioblastomas, they really have a bunch of these genes, and trouble with their metabolism in general, or the methylation, or all these things, right? Because she counsels other people that just really want diet and fitness recommendations, or if they're athletes or something like that. And she goes, all these people, they got great genes. There's nothing so ultimately, there is a link, right? There's something that sets you up for being a 34-year-old who gets tumors in 4 parts of your brain. And and again, my normal allopathic world would look at this like, see, I told you so, it's all the genes. But it's the genes related to metabolism. So really, it's a metabolic disease. And that's what they haven't quite come to yet with me. I still give talks all the time. I get all kinds of questions, and they just don't get the full link. That's the part.
That's the link that's really hard for people to see, because I think I've heard you talk about this before, is that it's not just the genes, it's how those genes are affecting metabolism in general.
Correct.
And so you're seeing this in real time with a lot of your patients that have glio and starting them on a ketogenic diet. I mean, because you're right, you do have those that look like they have no risk factors at all, that are 25 or 30 years of age. But I mean, I would imagine there's probably a significant subset of people that you also have seen that you can see these guys have metabolic dysfunction, and there's something we can do about it as well.
Exactly. Oh, absolutely. They almost all do. I mean, I see this, I just today in a consult, saw a wonderful Hispanic man who has a recurrent GBM, and he's got the belly out to here. He's metabolically, abnormal. It's not, we're not supposed to be. Do you
think, just a question that just came to me, do you think those kinds of people with more metabolic dysfunction that have a glio or a recurrent glio, do they have a better potential response because you have more to go? And it's like if you have 300 pounds to lose versus you have 20, it's easier to lose. It's easier to lose weight. Is there some, because of all the patients you've seen, is there any indication that makes them more treatment responsive if you can have a significant impact on their metabolic?
That's a great question. I honestly don't know the answer to that. I think that it is a challenge. I think that's something we'll have to look at, really. I really don't know. I'm looking back. Some of the patients that have been my most challenging are the ones that really are already fit and trim. Why did I get this? That they don't have a long way to go. So that's true.
Yeah, I would just be interesting thing to think about, right?
It would be. We'll have to look at that and see if that comes out.
Well, that actually brings up a question. I know that you're doing something you call phase 0 clinical trials over at Barrow, and I actually haven't heard this before, so I was actually reading a little bit about it. So when you're thinking about phase 0, what does that mean exactly, and maybe how some of these metabolic...
So this is something completely in the allopathic pharmaceutical-driven world, and it's not really related to the to the metabolic therapy, but it is something I have been involved with, and I have a bit of data and knowledge about it. I've enrolled many patients in phase 0-2 trials. So what it is in a shortcut is that there are drugs, many of them are already being used in other types of cancers. They may be PARP inhibitors or, alkylating agents or any new drug that might be very effective in breast cancer or colon cancer or melanoma or something like that. They've never really been tried in glioblastoma. Mm-hmm. And so the patients have almost always already had standard of care. They have a recurrence. We've already had their tumor before. They send it off for Caris or Tempus molecular profiling, and you look at, do they have an EGFR amplification, or do they have some other, thing that makes them that makes it so that this targeted agent might be effective or should be effective against their tumor. Mm. So the phase 0 part is they go on the drug for 5 days before surgery. They need surgery anyway for the recurrent tumor, but you put them on drug before surgery.
Got it.
And then when you take the tumor out, you send the cells for an assay to see, number one, was the drug there? Was it attaching? Was it showing activity against their tumor? And then if it did show activity against their tumor, then you continue on with phase 2 and they get that drug for 6 months. And you look at it, but it's still, so it's a pharmaceutical driven, clinical experimentation trial. Right. But it really brings up the point, and this is the thing that I've talked about ad nauseum so I'm part of the Ivy Brain Tumor Center, which does all of these trials. So Catherine Ivy, wonderful, and they donated $50 million. We have this whole big building with the largest center for these types of brain tumor trials in the world. So patients come through all the time. The struggle I have is that every single, Tuesday noon we have tumor board, mm-hmm. and we discuss usually about 20 to 30 patients with active, recurrent, or newly diagnosed, GBM. And it's the most frustrating, just ridiculous meeting, because I've been doing this for, like I say, 30 years, right?
Right.
And it's the same thing every single week. They did this standard therapy, tumor comes back. We tried this drug, it didn't work. Let's try a different drug. It's not working. So it's the idea of trying monotherapy, trying to hit one receptor, one thing, as if glioblastoma cells are not clonal. They're not the resultant of one mutation that happened and developed all these tumors.
Right.
And it only makes sense in the metabolic space to me. So it's like the stem cells, they're all been exposed to the same metabolic issues, and then they all go bad at different times. They're heterogeneous tumors. And so you can wipe out 50%, 70% if they have the EGFR receptor, if the PARP inhibitor works, something like that. But they all still, if you kill 70% of the cells and 30% still live and even more resistant than before, you've made no dent or a minor dent in their survival. But
Right.
if we treat the entire metabolic milieu that caused the thing to happen in the first place, sensitizes them so that radiation is more effective, or at least, or hyperbaric or something like that, we can save the patient, but change why did it happen. That's really, going at the root cause. So that's how I look at the metabolic therapy as the hopeful answer. So I have a whole protocol now. It took forever, but my nurse practitioners collecting data. We get our ketone measurements, our samples. Again, I published these first 16 anecdotal patients. We're trying to do a real prospective trial.
Oh, awesome.
People can be in the phase 0-2 trials, but also be in metabolic therapy. And at first,
so that was going to be my question. If you could do it, because
at first they were very nervous, saying, "Oh, I don't know, it might skew the data." I said, just think of it. It's only food. I'm not giving them some experimental drug.
Right.
And if it ends up skewing the data, hallelujah, right? Then we've actually proven something. This could be the most important finding of any brain tumor center in the world. And so this is what we're trying to do. Yeah.
That's awesome. So how is that going to work? It sounds like you have you've done the anecdotal piece. Now you're working on the prospective piece of it. Right. So maybe you can walk us through like what that actually means. I mean, obviously you have the regular standard of care, but do you have a whole team that's collecting data on the ketogenic diet and how people are following them and ketosis, and how's that going to look?
Yeah. So we sign everybody up. Hopefully when they're first consultation, I talk about this all day, every day with every patient. And then they get, like the patient today, if there's recurrent tumor, they're very excited. Oh my gosh, I heard that maybe I could change my food. So some people are really already pre-screened. They come to me because they know I do this and we help them. But others have never heard of it before, and it's a big struggle. But it takes weeks to months to really adapt and to change and to be able to do it. So my wife, bless her heart, she's the wonderfully dedicated dietitian that calls them and texts them and takes calls from them in their grocery store. Hey, can I buy this? Can I buy that? It really goes on. So she monitors them. And then we get them with the Keto Mojo unit. They measure their ketones, and the current iteration, actually they have an app. It automatically downloads their data to the website. So you don't have to worry about patient reporting. We know if they're compliant or not. We get that. So again, this is all happening now. I have zero data to share with you about how
that's great. This is exciting.
It's happened, but it is going on, and they can be enrolled in my trial in addition to any other trial. I don't care what drug they take. I don't care what phase 0 drug. It doesn't matter. Anybody can be on it and still just be followed, and then we'll monitor. Hopefully, a year from now, I'll be able to do a follow-up show and tell you what the actual data is and how it looks. But I can tell you from the ones I've seen, the ones that are doing it are remarkably better. It's a ketogenic diet is a remarkable COX-2 inhibitor, so the amount of edema they're on goes down. They don't need the dexamethasone, and all these things that you find in the standard of care practice get better. And we try to treat them with boswellia or berberine or all these other things if we can, to prevent them from going down the metabolic disaster pathway of taking dexamethasone.
Yeah, Dex is a challenge, especially if you want to stay in ketosis.
Exactly. It's really a challenge.
Yeah. I mean, a couple of things come to mind. I mean, so you mentioned that it's not just your trial that people can do this on. So there's other trials that are ongoing at Barrow where people can also go through and kind of work on the metabolic side along with some of the other drug trials that are ongoing. Okay.
Right.
Just want to make sure I understood that. And then the second question I had was regarding, I don't know if you've had an experience with exogenous ketones, if you've been thinking about how or when to use those in the setting of radiation, the setting of chemotherapy, or the setting of even surgical procedures themselves at all.
Right. So we've talked a lot about that. My wife and I, back and forth about exogenous ketones. And the issue is, I think that in the short term, they can be very useful for people to go through the keto flu or they feel like lack of energy, all stuff. But I really don't think it's necessarily, we found that the ketones themselves have activity modulating. It's an HDAC inhibitor. It can increase radiation sensitivity, so all this stuff. So the ketones themselves do something. But I think it's putting the body in the metabolic state that produces ketones that is probably fixing the metabolism to where they're responsive and getting, the real benefit from the treatment. So if someone is still thinking they can eat their Snickers bars and take exogenous ketones, I don't think that's the answer. I think that's really not going to be the crutch that's going to get you through. But I honestly don't know. It'd be a great trial. It's tough to do, but using the exogenous ketones, and if you really increase the number, is that really helping, or is it? My personal bias is that I think it's, like I said, the metabolic state that allows your body to be in ketosis and depriving the brain of glucose and using ketones as a fuel and all that stuff. I think that's important. And I hate to not everybody who does this has had a great response. There are patients out here that'll hear me and they say, wait a minute, Dr. Smith, I did that, and my tumor still came back, and I've seen this way too many times. And we have a real trouble. Dr. Thomas Seifert talks about this, about glutamine. So glutamine is a fermentable fuel. It's an amino acid, and it's like we need it. Every single cell in the world. You can't give a glutamine blocker without toxicity. So you get into that whole chemotherapy problem. But we somehow have to solve this. I'm convinced I have a few patients where if I would have had a good way to block glutamine, fermentation in the brain, and that we would be doing better. So it's not a solved problem. I don't want anyone out there to come out of this thinking, if I just go on a ketogenic diet with glioblastoma, it'll never come back. And I'll say, it's not that easy. I wish it were.
Yeah, I appreciate you saying that. I mean, certainly my experience, and yours is much greater than mine, is that it seems to help, number one, quality of life. I mean, people that are on the ketogenic diet, when they're going through radiation, chemotherapy, getting surgery, they just tend to do better. Has that been your experience?
Absolutely true. I can think of just numerous patients. One of them comes to mind right away, where this, wonderful youngish woman, she's 49, had a first diagnosis with me. Her dad was very involved in all kinds of therapy, decisions, and wanted all kinds of clinical trials. I talked him into the ketogenic approach. And so she promptly went on it. She was super religious about it, did great. And she was, survived more than 2 years, which is great, double the average. But it was but her number one comment was, I don't care if I have GBM or not. I feel better now than I ever felt in my life. Yeah. She was hiking, stuff she never did before. She lost 50 pounds. She was healthy thin, all the way through her whole disease process. And unfortunately, like I said, probably using glutamine, but and it did recur. But she really, really did well. She was very happy, high energy, high quality of life during her whole treatment. No edema, never had to put her on Dex or anything else. So it was really quite good for that.
Right. And I think that's been my experience too, is that, I mean, certainly it's not going to work for everybody. And being in ketosis is not easy for many people too. It might be because some of the genetic polymorphisms that you were describing. It might be because it's just hard for some people to maintain. And even though there's lots of resources out here as well, but short term, definitely a benefit for getting through some of the more interventional things. And then even long term, having the ability to maintain this, as you mentioned with this particular patient of yours, it seems like they can, at the very least, I've had people live longer than the average, using this approach, and if not, much longer in some cases. But of course, most people with glio will still die, and even if they beat double the average, that's 2 years, right? Right. So it's not like it's a huge amount of time. Huge, yeah. So I mean, when you're looking at, the metabolic approach here, do you ever, I know that you have Naisha Winters and that crew, do you ever work with them in conjunction, in the sense of doing a lot of so Naisha's program used to be called Metabolic Terrain, but I don't know what it's called now, but
she uses the terrain for sure. No, I'm in contact with her a fair amount, and she refers to patients, and sometimes she's so high up there in this whole scheme, and it's hard for her to have individual time for individual patients, but she'll allow me to consult with her and go through the genome with them. So yes, we try to stay in touch, and she's helped out many of my patients.
Yeah, I mean, that seems it seems to be like the real key here is that, part of the work that I do, we have a nonprofit organization that sponsors this podcast. It's a foundational approach to health, looking at mitochondrial function. It's looking at cellular metabolism. It's looking at metabolomics. So it's sort of like a couple steps up from genomics, right? So genomics is really important because it gives you a sense of what may be happening, but it's actually metabolomics metabolomics that actually gives you a real sense of what's actually happening in the cells right now. So how well they're making energy, how well you're detoxifying from energy metabolism. And I've had a lot of conversations with Naisha about, just how important this approach is, looking at all these aspects for anybody, but especially for patients with glioblastoma and other types of cancers that, it didn't just happen overnight, right? And I think that that's really important. So when people are listening to this, I think it's important to think, well, what are we doing now? So nobody wants to get glio, right? So it's a death sentence. And so at least at this point, except for the very, very few people that both you and I know that have lived for longer periods of time, without recurrences or are still alive today. When you think about sort of long-term for people, when they're looking to optimize their health, do you think that a metabolic approach is important for everybody?
Absolutely. I'm convinced of that. I have a book that I'm trying to get published that I need to sign a contract for. So if you know a great publisher, that's great. But no, it is all about that. It's that this is way better at prevention than it is at cure. And if you look at the headlines just this last week, they talked about life expectancy for men in the United States is down to only 70 years. The number, there are over 8 million people in America now with mild cognitive impairment, expected to double, by 2030. The rate of Alzheimer's disease, all this stuff. And why is all of this happening? And I will tell you, the proposed title of my book is Food for Thought. If you want to keep thinking, keep thinking clearly, you got to treat your brain correctly by giving it the right food, right? It's the idea of just putting in junk and expecting it to function. It works when you're 20 and 30, but by the time you're 50, 60, 70, and you see people like I do every day in clinic in my office, I see people that are my same age, and they have a diagnosis of NPH, which is normal pressure hydrocephalus, which is not a fluid problem. It's a brain inflammation problem. It's a brain atrophy problem and it responds temporarily to a shunt, but that's a Band-Aid. It's something where these mild cognitive impairment, where they got memory lapse and all this stuff, it's totally avoidable, completely 100% avoidable. But you have to start, you can't just abuse your brain and then expect it to heal and recover. Your brain is the most dynamic organ in the body. It uses 20% of your energy that you consume. Your blood flow, liter a minute is going up there and come back down, and all of these things that you consume and eat, and be it plastics and microtoxins or molds or who knows what, but on top of that, just junk food, just trans fats, just all this stuff, just your mitochondrial energy, a single neuron going down from your motor strip down to your leg, to move, can have 10,000 mitochondria. So you have to be able to have all of those mitochondria be healthy and functioning, give you energy, and having, I was a complete, before my old metamorphosis, with the book, the low carbohydrate living thing, I was a sugar addict. I mean, I had Snickers bars all the time. I thought, it was like if I didn't eat by noon, my stomach was. I could tell you the time of day if I went 3 hours between eating something, I was going to die.
Yeah,
right? And it just
a roller coaster.
When I first went through this, my wife was so sick of me saying it. I would be like, it's 4 p.m. I haven't eaten yet. I can't believe this. I'm fine. I'm surviving. I'm actually thriving. I feel okay. I'm mentally sharp. It's like this thing that people that have never done it don't get. It's like you can just live a perfectly unstressful life relative to food. You don't need it every hour. You're fine for a while.
Yeah, that's beautifully said. So the book, tentatively titled "The Food for Thought," what is the arc of the book? Is it talking about your personal story, I would imagine, and also some of the experience with patients, or what are you hoping to accomplish?
Yes, it's all about that. It's I give my personal story, my father's story, but unfortunately my mother has Alzheimer's disease, right? So I've got a father had glioblastoma, a mother with Alzheimer's disease, two worst diseases you could think of. And I just visited her yesterday, and bless her heart, she recognized me, thank goodness, but she won't remember. She didn't remember 10 minutes after I left that I had visited her, right? So
of course, yeah.
It's memory function. So as an epilepsy tumor, specialist, all that stuff, the hippocampus, the way your hippocampus stores your memories in you, is so dependent on healthy substrates being in your brain, and exercise, diet can't be overemphasized as far as maintaining that ability to remember. And there are people who do it right. There's a great man who I've heard of who is skiing every day in the wintertime at Snowbird, Utah. He's 103. That's going to be me. I mean, I'm telling you, it's like, this is what we can look for. You don't have to have you don't get old and creaky and all this stuff. I mean, I'm 62 and I feel the same as I did when I was 40. I really do. I run and I ski and I play tennis every week. There's stuff that you just, you need to maintain this quality of life. And I am absolutely 100% convinced when you see these people who come in with a big round tummy and they've already had their knees replaced and they're inflamed everywhere and they can't think, they have memory lapses, their ventricles are expanded, their brain is atrophied. It's all because of our crappy American food. And people go over to Europe and, they outlawed GMO foods 30 years ago. And I tell you, we went on a ski vacation as a family over the holidays to Chamonix a few years ago. And I noticed in the entire town, it's like I didn't see a single obese person, not until we got to the airport coming back to America. And then you come back, you live like there's the French, the fat paradox. I mean, they eat their cream and their wine and their cheese and all stuff, and they're fine, right? But
because they're moving all the time.
They're
right?
They're moving, but they're eating. They go to this, local, store. They buy some salads. They have olive oil and everything. They're doing things and being active and mentally and socially and all this stuff. As opposed to we get in our cars, we go to the drive-through. We had a layover in Detroit, and we stopped. We tried to find something to eat in the layover. And there's a Red Robin restaurant or something. I don't mean to throw them under the bus, but it's like every employee in there was 100 pounds overweight. Every item on the menu was fried. It was like trans fats everywhere. You got your, sugary desserts, your milkshakes, and your French fries. And it's like, and you look around the airport, 90% of people are inflamed and obese. You're just wondering, this is a disaster. We have a critical, absolute public health disaster in America. Because of our food.
Yeah, I think that I was talking to another doc. His actually last name is the same as mine. His name's Dr. Brett Sher, spelled a little bit differently. Mm-hmm. And he's on the podcast. We're talking about his company called Metabolic Minds. Mm-hmm. And Metabolic Minds is a company that's working on the ketogenic diet for things like bipolar disorder and depression and for Alzheimer's and things like that, because we know as we get older, our brains are not as good at processing glucose, but we always can do ketones very well, the fat byproducts, to make energy. So I think it's really important to know that metabolic therapies, the category doesn't have to be the ketogenic diet, but in general, when we're talking about metabolic therapy, people sometimes get confused as to what we mean. But in general, it is optimizing metabolism, making sure you can make energy well, making sure you can detox from the energy that you're making, and then making sure that you feel good as a result of being in a metabolic place. Because unfortunately, I think about 95% of patients, 95% of Americans in the United States are metabolically unhealthy and as adults.
I agree.
So, and we know this. I mean, you can see this when you're in Detroit, and you can see this when you're in almost any place that you go these days, unfortunately. So if it's 95% of people, like the people listening, 95% of them, maybe not that much, because it's a different subset of people.
They're listening, but
yes, exactly. But I think the key, and I'm wondering what you think here, Kris, is that the thing is that you have to test and see what's going on, right? You have to know what's happening to your mitochondrial function, to your energy metabolism, to your gut and to your neurotransmitters, and think and be prophylactic about it. Because as you said, once you have something like glio, like it's very difficult, especially for that tumor, but almost for any tumor, to go away. Do you have a sense of doing testing and being pretty well just dialed in that capacity is really important too?
It's very important. There's a whole series of labs that all of my patients get.
Okay.
Trying to get their LDH isozymes and their glucose numbers and their hemoglobin A1C. There's several different factors that you can get. And I have one of my patients who I'm so proud of her. She's 34. She got 4 kids, and she's got a recurrent GBM we're battling, and she's actually thriving. I mean, she's doing better. She's gone through a ton of stuff. It's not been easy. It's been the most difficult thing. I think she's had 14 surgeries now in the last 13-year survivor of a GBM. But
13 years.
Yeah.
Wow.
But her hemoglobin A1C number was 4.1, right? And
Wow. That's
yeah,
low.
she's really doing good. Her brain is using ketones for fuel.
My
She is
goodness.
not using glucose very much at all. And her last
That's amazing.
scans, the last 2 scans in a row, are showing shrinkage, resolution. I'm just so encouraged by her. She's
Yeah.
really, a soft spot in my heart for her. And so
Yeah. Yeah.
there are things that we do. And I see people with the worst diseases in the world, all these brain problems, all these brain tumors and stuff. And I am convinced that much of it would be prevented if we did not have such a horrible standard of living in America with our car,
Sure.
based society, and not walking and shopping at massive Costco preserved foods, and as opposed to local farms originally, organically farmed, regenerative farmed, beef and all that stuff. So
Yeah, I'm 100% with you. I mean, we know that the rate of GBM 100 years ago was nothing like it is now, for example, right?
No, and it's really unheard of in nature. So you think of chimpanzees in the wild. It's not like they've gone out and slaughtered millions of chimpanzees and looked for them, but it really is an unheard of disease in the wild. This is something, right. And there's a really good study out. I had this in my last grand rounds that I gave on this topic. Every single type of cancer is at least twice as likely in a developed country versus an undeveloped country. Every single type, including GBM, but we're a small percentage of the lung cancers and colon cancer, all that stuff. But you live in a developed country in North America, right on the top of the list, and Western Europe, then it's just up compared to. So you eat this processed food, and you have a stressful lifestyle, and you don't get out and walk, you don't work out in the fields, all this stuff. You're just setting yourself up for cancer to develop in your body. So that proves it's not a genetic thing. It's literally an environmental lifestyle disease.
Yeah, I mean, I couldn't have said it better myself. So I know I've taken a lot of your time, Kris, today, and I want to finish up on time because I know you have patients and things to go do. So my final question to you is more of a kind of a global question that we ask all of our guests, and I didn't prompt you because I always think it's more interesting, especially for people that are used to be working on their feet for a 10-hour neurosurgery. Like right. You have more patience than God, as far as I'm concerned. Although a lot of neurosurgeons do think they're God. I know maybe you don't.
That's a whole other story. That's right.
But the question is this. So, our podcast is called the Smarter Not Harder podcast. And so I ask all my guests at the end, if they had 3 tips for anybody that's listening.
I lost you.
Oh no, did you lose me? Am I back?
Yeah, you're back.
Okay. So 3 tips that I ask everybody to live a life smarter, not harder. And it can be anything that you want to talk about. It could be anything from personal, professional, or whatever. I mean, it could be related to cancer or not. But 3 ways that you think anybody can live smarter, not harder.
So one of the biggest things that has changed, I never would have thought I would be involved in, is I've become a true yogi. So I did my yoga this morning, and and it was a day that I didn't have to come in early, and it was a beautiful day in Phoenix, where at this time of year there's a cloud cover, which we almost never have, and it was just gorgeous. But I was out by my pool and looking out over the landscape and over the trees and with the birds, and just literally taking time to just meditate and move and stretch and enjoy and just contemplate life. And I think out there we have where our family dog died a few years ago. I have a little grave plot out there for her, and it's like, yeah, we live, we die. It's acceptance of like the immortality, but also that while you're here, just enjoy the moments, breathe in the breaths, and really have the ability to do that. Excuse me. Yeah. So it's really been a great part of my life. I really look forward to it, the days when I can do a true yoga meditative thing, and that is clearly smarter, not harder. I don't think it's a hard thing to do.
Yeah,
it really is. In Shavasana, I just lie there and think and breathe. It's been a terrific part of my own personal healing, and helps me. It's a stressful job, taking out people's brain tumors and thinking about complications and what we could do, and guiding them through, get attached to them and watching them go through this dying process year after year. I just need that so much. So that's been a big deal for me.
I love that. Yeah. And so if Kris, if people want to learn more about you and your work, is the best place to go to Barrow and learn about you and what's going on?
Yeah. We have a good website, and you can dial me in. You can see some videos that I've done, and we have a second opinion program and all this stuff. And hopefully someday my book will get published and a little more presence on that. But
I love that. Yeah. Well, Nation knows a good publisher. I know that. So
okay, great.
We'll find you one.
Okay,
but,
great.
Kris,
all right.
Thanks so much for your time, and I appreciate all of the hard work and amazing things that you're doing in the world.
Thank you. Thank you so much. It's been my pleasure, my honor. Thank you.
Have a great day.
Thanks. Bye-bye.
Thank you so much for tuning in to another episode of the Smarter Not Harder podcast, your home for $64,000 questions and 1 cent solutions to those $64,000 questions. This is a great episode with Dr. Kris Smith. I really enjoyed speaking to him and speaking about metabolic therapies, glioblastoma, but so much more than that, and understanding that metabolic therapies are for everyone. It doesn't always have to mean the ketogenic diet, but it can mean and should mean looking at your mitochondrial function, your cellular optimization strategies, testing, not guessing. Please like and subscribe so you never miss an episode of the Smarter Not Harder podcast, and we'll see you next time.